Now that we know our leading term is x to the 7th and it's a negative term, all we're going to do now is figure out end behavior. We'll look at this example and then we'll look at a whole bunch of others just to see how it works out. So, odd. Odd means it either goes down and up or up and down. Negative. Negative means it starts up and goes down. So let's think about this again. If we plug in negative 50 million, we would get 7 of those factors and then one more negative factor. That would be 8 negative factors. That's a positive value. So anything to the left is going to give us an increasingly larger positive value. Since it's odd, if we start up, we end down. And then again, if we plug in a positive value here, we would get 7 positive factors and 1 negative factor, which gives us a negative value. So any value we plug in for x increasing to the left is larger and larger x, but it gives us a larger and larger negative result. So our end behavior is going to be down. That's it. End behavior for an x to the 7th leading term polynomial, where that leading term is negative, starts up, ends down. Only difference here at this next example is our leading term has an even number of exponents, the 8 here. So if we're even, we're either going to be both up or both down. If we're negative, that means we're both down. You plug in a large negative value here 8 times, and that gives you a positive result. But then you give it one more negative factor, and you get a negative result. If you plug in a positive value here, you get a positive result. And then one more negative value, and you get a negative result. End behavior for an even exponent leading term, which is negative, is down and down. Let's look at the next part. Alright, so here our example has that even exponent, but we're going to look at a positive leading term. Here's an example of a polynomial that has that even exponent, but is a positive leading term. It tells us 2 things. The evenness tells us that both ends go up or both ends go down. And the positive aspect tells us that both ends go up. So end behavior here, up and up. If we plug in some negative value, we multiply it by itself 8 times, that gives us a positive result. It was positive to start with, so we're positive way up. If we plug in a positive here, multiply by itself 8 times, that gives us a positive result. We multiply it by another positive, since it was positive originally, and that gives us a positive result. One last option, what happens when it's odd and positive? Let's look at that. Alright, other option, leading term has an odd exponent, but the leading term itself is positive. That means that we're going to start negative when x is negative. And since it's odd, we're going to end in the opposite direction. We're going to go up when x is positive. So let's look at all 4 options all together, and you can really see the breakdown. So here we have only 4 possible results of end behavior for the graphs of a polynomial. It's dependent on the exponent of the leading term, whether that's odd or even, and the sign of the leading term, whether that's positive or negative. So our first example here, 4x cubed, has an odd exponent and a positive coefficient. Positive 4x cubed. Positive, odd. That means we're going to start down and go up. Next example, negative, odd. The exponent is odd, the coefficient is negative. That means we're going to start up and go down. positive, even. That means we're going up and up. Negative, even. That means we're going down and down. Again, these are the only 4 possible results for end behavior of the graph of a polynomial.